My name is Don Morrill, and I lead solutions architecture for Alexa. We're here to talk to you today about the Alexa voice service. We're going to talk about what the Alexa voice service is, and we're going to give you a little peek under the hood. How do we instrument Alexa? You know, many of you are probably familiar with Echo, and we're going to have a quick demo of Echo today, but we're going to talk a lot about Alexa under the hood. So hopefully you'll enjoy the talk. Today, I'm happy to be joined by one of my colleagues, Frederic Derma, who is a principal engineer with Amazon Alexa. He'll be the one actually giving the under-the-hood portion of the presentation. And then we have Stephen Chen from the technology group of BMW, who's going to here today to talk about how BMW is thinking about voice and Alexa specifically in the car environment. So we're really happy to have Stephen with us today to talk about that. So they'll be back up with us in just a minute. Before we get started, though, you know, this is a quick commentary. This is my 4th reInvent. I've been here for every single reInvent, and I've seen it grown year after year after year. And every year I come here, I think it couldn't get any bigger. It couldn't get any more exciting. We couldn't have more customers here. We couldn't have more partners here. And every year, somehow, we manage to outdo ourselves. And it's in no small part to the customers and the partners that we work with. And I want to just say thank you to the AWS and Amazon customers for putting your trust in us and for helping us make reInvent as big as it's been every year. So thank you very much. We appreciate that. And so a quick walk through the agenda. The first thing I'm going to do is give a quick Echo demo for those of you that might not have seen Echo up close and in person, but it's also going to set the context for the rest of the discussion. So I'll be walking through some specific scenarios with Echo that are going to be relevant later on in the talk. Then I'm going to talk about what is the Alexa voice service. There are several products in our Alexa portfolio, in our SDK and developer portfolio. So I want to make sure everybody understands what Alexa voice service is and what it isn't. And then I'll do a quick walkthrough of the APIs. So we'll walk through the actual APIs that you use to implement Alexa on your devices. And then I'm going to turn it over to Frederic, and Frederic is going to talk about some tips and tricks, things to consider as you're incorporating Alexa into your devices and into your apps. And then Frederic is going to get to what I consider the meat of the conversation, which is an interesting peek under the hood in some of the magic that makes Alexa work the way she does. And then finally, again, we're really excited to have BMW up here today talking about their experience with speech and with Alexa and how they see that playing out in the automotive space. Excuse me. So a quick show of hands. How many people here actually own an Echo? Wow, not bad. That's pretty good. How many people have seen an Echo in action up close? Probably a lot of you, because we have some on the show floor. But good, there's a good portion of people that haven't seen an Echo up close and in person. So I'm going to give a quick demo of Alexa on Echo, and then I'm going to talk through some of the scenarios that are important for this conversation. So this is an Echo. It's in mute mode right now, and you can see that because it's got a big red ring on it. It's not listening to us. So I'm going to take it off of mute mode. If I didn't have it on mute mode, it'd be waking up every 5 seconds during our talk, and that wouldn't be good for anybody. Alexa, what time is it?
It's 5:35.
Alexa, what's the weather in Las Vegas?
Right now in Las Vegas, Nevada, it's 91 degrees with clear skies and sun. Tonight's forecast has just a few clouds in the sky and a low of 67 degrees.
Now, one thing I forgot to mention is if you look up on the screen, I've switched over to what we call our companion application. So either on a mobile phone or in a web browser, there's lots of additional information that you can gather about what Alexa is telling you. And I'm going to talk a little bit more about the companion app in just a few slides. So just appreciate it for what it is, and I'll describe it in a little bit more detail later. Here's the tricky question. Alexa, who is Jeff Bezos?
Jeffrey Preston Bezos, born January 12th. 1964, is the founder, president, chief executive officer, and chairman of the board of Amazon.
So those are examples of some of the skills that Alexa can offer you. There's lots of other capabilities that Alexa has. Alexa, what was the score of the last Seattle Seahawks game?
On Monday, the Seahawks beat the Lions, 13-10. They'll play this Sunday at 10 a.m. in Cincinnati, Ohio against the Bengals.
Come on, I know there's some Seattle fans out there. Let's go. Excuse me. So those are examples of what we call single turn intents. And what that means is that I ask Alexa a simple question. There's no ambiguity in that question, and she's able to respond to me with a response. Alexa and AVS also support what we call multi-turn intents. And so I want to use our timers and alarms feature to show you what we mean by multi-turn intents, because we're going to talk about that a little bit later. Alexa, set a timer.
For how long?
1 minute.
1 minute, starting now.
Alexa, set a timer.
For how long?
5 minutes.
Second timer, 5 minutes, starting now.
Alexa, cancel timer.
Cancel which timer? 5 minutes or 1 minute?
1 minute.
1 minute timer canceled.
Alexa, cancel timer.
5 minutes timer canceled.
So those are examples of what we call multi-turn intents. Alexa didn't have enough information to complete the action that I requested of her, and so we engaged in this dialogue where she came back and said, how long do you want to set the timer for, or which timer do you wish to cancel? And we'll talk a little bit more about that later. Finally, a couple of really interesting skills that Alexa have that people find quite enjoyable. Alexa, tell me a joke. Alexa, tell me a joke.
Do you want to hear a pizza joke? Never mind. It's pretty cheesy.
We're pretty proud of our cheesy joke inventory on Alexa. And finally, the skill, mistake there. And finally, something that is probably the most popular use case with Echo today. Alexa, play some music from iHeartRadio. Alexa, play some music from iHeartRadio.
Getting the last iHeartRadio station you listen to. Pitbull.
Alexa, stop. And so that's a quick demonstration of Echo and of Alexa. Thanks. And so before we get into the Alexa voice service, I want to first, as I said earlier, talk about what Alexa voice service isn't and what are some of the other products and capabilities in our portfolio. The first one is what we call ASK, or the Alexa Skills Kit. And the Alexa has certain built-in skills or native skills, and the ability to tell the weather, or the ability to play music, or the ability to play sports scores back to you is a native skill of Alexa. But what we've done is we've taken it one step further, and we built this thing called the Alexa Skills Kit, which allows you as developers to come in and develop your own capabilities for Alexa. And we make it pretty easy. Within a couple of hours, you can probably have your own custom Alexa skill up and running so that you can ask Echo, or you can ask any AVS or Alexa-enabled device for that skill. For example, if you're a horoscope provider, Alexa today doesn't have built-in capability to tell horoscopes, but you could build a skill that says, Alexa, ask horoscope for Pisces, and then you could actually return some text to the Alexa engine, and Alexa will text to speech. So you'll hear it in the native Alexa voice. You'll hear the response right back to the Echo device or whatever device you happen to have that is Alexa enabled. So that's the Alexa Skills Kit, but that's not the focus of today's conversation. The other piece of our ecosystem is the Alexa companion app, and you saw a brief demonstration of that. Most people run it on a mobile phone or a mobile device, and this is an important piece of the whole Alexa ecosystem. It's the interface by which you register your Echo device initially, you set up your device, you provide your login credentials, you view and manage your Alexa actions, so you saw kind of what we call a card stream of all the interactions that you've had with Alexa. You can see a history of the interactions. You can link your third-party accounts with this as well. So you heard me ask her to play some songs from iHeartRadio. In order to do that, she has to authenticate against iHeartRadio, and you need to provide her with your iHeartRadio credentials so she can do that. So the companion app is the thing that you do that in. It also has the ability to create to-do lists and shopping lists, and so you can, if you're in the home and you say, Alexa, add milk to my to-do list or my shopping list, you can take your companion app into the grocery store with you. Hopefully you'll purchase the milk on Amazon Fresh someday. But you could take it to the grocery store with you, and you can actually have your list right there in your pocket. And there's lots more that the companion app can do as well. So that brings us to AVS, or the Alexa Voice Service proper. At its core, the Alexa Voice Service is relatively simple. If you have a device or an app running on a phone that has a microphone and a speaker, you can use the Alexa Voice Service API to capture audio and send it up to the Alexa cloud. It's a RESTful API today, and Frederick is going to talk about some of the other protocol ideas that we're thinking about. And Alexa is going to send an audio back to you in MP3 format, and you simply play that audio back to the user, and we've text-to-speeched it for you. We've set the intonation, and we've set the Alexa personality, and so all you do is simply play that back to your user. And so how do I use the Alexa voice service? I want to walk you through quickly our APIs and our process for setting it up. So the first thing you need to do if you're an Alexa voice service developer is you need to authenticate your user or authenticate your device. This is something that I've obviously done with the Echo already using the companion app. But what we've done is we've implemented the OAuth protocol, and it's a little complicated. There's a bit of a dance that has to happen between passing secure token information between your companion application. We also use login with Amazon in order to do the authentication. So there's a redirect to login with Amazon where the user provides their Amazon credentials. And ultimately, that makes its way through, and there's some handoffs and redirections that happen. But the end result is that an authorization token is sent down to your Alexa-enabled device, and it's that authentication token that is passed along with the API calls that allows you to access the Alexa voice service. The authentication token is short-lived, so for security purposes, that authentication token is only valid for 1 hour. So what we also give you is something called a refresh token. And so after an hour is up, you go and you request a fresh refresh token and a fresh authentication token using that refresh token, and that kind of keeps if that key happens to get compromised for whatever reason, it's only valid for 1 hour, and then it expires, and you have to go fetch a new one. One thing I should point out, a lot of what I'm telling you today is available in a reference implementation that we have on our website. It's written in Java, so you can take a look at it, and it kind of extracts away a lot of the lower-level API concepts that we're going to be talking about today. And so at its core, AVS today is a RESTful API. There's no magic here, but the basics of an AVS request. You create an HTTP request. You set up the HTTP headers. You collect the audio from the user. However, whatever way you use to interact with the hardware on your device, you collect the audio. There's two ways you can send audio up to Alexa. You can send it in what we call chunked mode. You can actually pseudo stream the audio up to the Alexa cloud over the HTTP protocol, and Frederick's going to talk a little bit about that later on. Or if you have the audio already, you can set a content length and send the whole packet up all together. One thing I want to emphasize, as you're collecting audio from your end user, it's important to us, we take a lot of pride in making sure that the end users are comfortable with the Alexa experience. For example, that light turns red when Alexa is not listening, so the consumers are comfortable knowing that Alexa isn't listening. And we're encouraging and asking very strongly of our AVS users and our AVS developers not to store any of the audio locally. In order to build that trust with the consumer, we want to make sure that their data and their utterances are protected as much as possible. So once you've collected the audio, you send it up to Alexa, and then she's going to send back a series of responses to you. And we're going to talk about those responses in a minute. So obviously, you get the responses, you process the responses, and usually there's some follow-up action that happens as a result of the request. And so one response can have multiple what we call directives or sections to it, and so we'll talk about that in just a minute, how you process those directives. And so here's a very simple example of an Alexa request. I'm right-handed, so I'm going to point to this screen, but hopefully most of you can just follow along. So this is a simple HTTP request. You can see that this is a request to our speech recognizer service, and the request that we're asking for is to recognize. That's kind of the most basic request for Alexa. You're asking her to recognize speech. There's a host there. There's an authorization header, and you can see right in there you would plug in the access token that we spoke about earlier, plug in the access token, and you should be on your way. And then also you specify the way that you're sending the audio, whether you're sending it kind of pseudo-streaming, you would set the transfer encoding to chunked, or if you have the whole audio already captured and you know the size of it, you can set the content length instead. And so after you've set up the headers, you're going to send the actual request in JSON in the message body. And there's a couple of parameters that are interesting here to us. The first one is this profile, which we call the speech model. Today, Alexa operates, or I should say the Alexa voice service operates in what we call a close talk or a push-to-talk model. That is, you're pushing a button on a device, or you're pushing a button on your mobile device, and you're speaking relatively close to the microphone. And depending on where you are relative to the microphone on the device and what's going on in the background, there are actually different speech models that we can apply to the voice that you're sending to us. Echo, for example, is what we call a far-field device. There's a lot of science that goes into the microphone array and the wake word, and so there's a different speech model associated with that than there is for Alexa voice service. So today, you would specify the Alexa close talk speech model. And I think Frederick is going to talk a little bit about the other speech models. Locale is US English today. Today, Alexa supports US English. As you can imagine, Amazon is a global company, and we're always looking at areas for expansion. So, we are thinking about other languages in the future. You also specify the audio. So when you capture the audio going up to Alexa has to be sent up in 16-bit depth PCM at a sampling rate of 16 kilohertz. That's the model that Alexa is expecting to compare to when she looks at the audio. You can compress the data using the Opus compression algorithm if you choose, but PCM is just fine for us. And so when I get the response back from Alexa, she's going to send back what we call consider a series of directives, and I'll point you through an exhaustive list of the directives in just a minute. And you can see the directives come in here. The namespace, Frederick is going to talk more about namespaces, but some of the things that I can do when Alexa responds is I can play some audio back to the user. I can play a speech synthesized, the time is 2:45 or what it happens to be. But a lot of what Alexa does is also related to streaming as well. And so I might be handed back a music URL or a chapter from an audiobook, for example, and I need to process that. So in the most basic form, you're going to get a directive back, and if that directive happens to be speak, you're going to get an MP3 file right here, and all you simply do is play that MP3 file back to the user, and you're done. This is a list today of the response directives that you need to expect and be able to process from Alexa. Clear queue has to do with the streaming queue. If you've got a queue of songs to be played or chapters in an audiobook, for example, this is a directive to, hey, clear your audio queue. Listen is a directive that is associated with what we call that multi-turn, right? So if I ask Alexa to set a timer, but she needs to know how long the timer, you'll get two directives in that response. You'll get a speak directive, which says, how long would you like to set the timer for? But you'll also get a listen directive, which says you need to open up your microphone again and capture some additional audio information in order to send it back up to Alexa. Play actually plays a streaming URL. You'll be handed a streaming URL to play back to the end user. It could be music, it could be audiobooks, it could be news. We have a feature called a flash briefing where you can get little snippets of news back and play them in a streaming fashion. Speak is pretty obvious. You take the MP3 file that we sent you and you speak it back to the user. And stop is pretty obvious as well, stop streaming. So I want to talk about streaming a little bit. Like I said, a very popular use case for Alexa and for AVS is the streaming of audio and music in particular. But again, it doesn't have to be music. It could be an Audible audiobook. It could be a news briefing. It could be NPR, any number of pieces of content. And so what we're going to do is we're going to send you the streaming URL to that content. But what that means is that we kind of lose track of what's going on the client side, right? You're not interacting with Alexa anymore, you're interacting with the streaming source at that time. So there's a number of streaming events that go up and down. You need to understand how to process and handle those streaming events so that if there's a playback error or playback finished or playback is interrupted, that you send those events back up to Alexa so Alexa understands what's going on. And there's a number of reasons for that. We want to keep track of what music is being played, what audiobooks are being played, but we also want to make sure that we render, for example, the companion app properly. So it's important that you understand how the streaming protocol works. And again, this is all kind of self-documented in the reference implementation that we have on our website. You can go to developer.amazon.com/Alexa and simply get started there. So that's a quick overview of the Alexa Voice Service API. I'd like to invite Frederick up now to give you that peek under the hood.
Thank you. Thanks, Don. So I will talk about the Alexa platform and some of its inner workings. So first and foremost, Alexa is a platform. Echo is just one device that you can use to access Alexa's skills. The Alexa platform itself is device agnostic. Built-in skills, or any skill that you build with the Alexa SDK, are automatically available on any device that integrates with the AVS API. All of Alexa's core functions run in the cloud. Automated speech recognition, through which we understand what you say. Natural language understanding, through which we understand the underlying intent, what you mean and what you're trying to accomplish. Skills, the application logic that we use to determine what action we should take for a given intent. Text-to-speech, through which we produce a spoken response. An event bus, through which we publish activity to the Alexa companion application that you saw earlier. And finally, a whole machine learning infrastructure that we use to continuously improve Alexa, both globally across all users and in a tailored fashion for each individual user. So all of Alexa's application logic also resides in the cloud. However, the platform itself is application agnostic. The AVS API that you see here encapsulates foundational device-side capabilities. It does not convey or assume any application-specific logic. The API is minimal. It's composed of a handful of interfaces for core speech and speech output functions, and interfaces for device-side capabilities we depend on, such as music playback. Porting your device to AVS is a one-time effort. Once you've done the integration, all of Alexa's functions, current and future, are available on your device. You can think of these interfaces as device drivers that you have to port or implement once and for all. Each of these interfaces, they're composed of a set of directives, actions that your client needs to take, and events that you need to send back to Alexa to let her know about the state of your device. So Don showed us the REST HTTP binding of the AVS API, how metadata and structured data is sent up and down in the body of a request, and how we use a multi-part encoding scheme to send binary data along with those requests. The platform, though, does not make any assumptions about protocol. Internally, it simply operates against these messages that have a header section for name and other metadata, a payload with data specific to a given message type. So in this case, it's a speech recognition message. So here we have attributes about the audio, what's the sampling rate, for instance. And then an optional binary attachment, in this case, the actual speech audio stream that we will decode in the cloud. So as a matter of fact, we use the exact same message structure across the full Alexa SDK API suite, not just for AVS. For instance, if you want to integrate with our connected home lighting API, which is showcased on the IoT Pavilion, you do it exactly the same way. You write adapters for directives, such as the one you see here, which this one would be issued if the user said, for instance, dim my kitchen lights. The programming model is the same, whether you use an Alexa-enabled device or whether you want Alexa to control your device. The audio player interface also illustrates the minimal nature of the API. We send down a handful of directives, such as play, pause, and stop, and you send us back life cycle events. But all the playlist management and queue navigation logic lives in the cloud. You, for instance, just send us events to tell us that you're about to run out of audio to play, and we then preemptively send you down the next track so you can start pre-buffering, but no queuing logic on the actual device. So again, the AVS API is application agnostic. The audio player interface is not a music interface. It's a generic interface that is used across multiple skills. The Alexa music experience is just one such skill. It's also used for flash briefing, through which we give you news stories, audiobooks, where instead of sending down songs, we send down news stories or book chapters. So let me talk a little bit about far field here. So when you handle a speech request, there are two events that you need to consider. What we call start of speech. So how do we know that a speech request has been initiated? And end of speech, how do we know that a speech request is complete? So there are several ways you can do that. If you have a remote with a microphone, you can do it by pushing and holding a button. But with the Echo, we identify the start of speech through an embedded wake word engine, and we detect the end of speech actually in the cloud, not on device. So the REST HTTP API that we have now works for the push and hold scenario because it's the responsibility of the client to surface both events. It's a simple request-reply interaction, and HTTP REST is sufficient. For the far-field scenario where we have the end of speech in the cloud, we need a more sophisticated protocol, asynchronous and bidirectional, because the end of speech will be detected by the cloud and the device will be notified. And as the AVS API evolves, we will support those type of protocols as well. And therefore, we recommend that, in as much as possible, you try to insulate yourself from protocol-specific considerations in your application logic. Note that AVS is a streaming API in all cases, so even in the REST HTTP case, you can stream the audio as soon as the user starts speaking, and we recommend doing that in order to minimize the perceived latency. So if you send the audio as soon as the user speaks, we can also start processing it in real time and handle it as soon as possible. As I said earlier, Alexa is protocol agnostic. REST HTTP is just one binding, both for data coming up and data coming back down. One I want to point out in particular that is showcased in our Connected Home API is Lambda. So here we forward the responses for a given request back to a device through a Lambda function that you can implement yourself and, for instance, communicate back to your cloud, an IoT cloud, if you have one. Okay, so now let's kind of look at AVS under the hood. So as we've seen, Alexa combines two concepts. We have a concept of intents and a concept of directives. Intent is a speech concept. It's a semantic representation of what the user wants. It is statistical, meaning that when there's ambiguity, the platform tries to have a hypothesis about what the best interpretation is for that particular case. And it is an input to the application layer, or to what we call the skills layer. Directive is an application concept. It's a representation of the action that we should take. It's deterministic, and it's an output of the skills application layer. So the Alexa SDK is all-encompassing and allows you to plug in at either level. You can define a new skill where you control the voice user experience and provide all the artifacts that are required. So intent, schema, and sample utterances. And in this case, the input to your logic is an intent. You can extend existing skills and tap into predefined voice experiences, for instance, through the Lighting API of the Connected Home skill. In this case, the input to your code is a directive. The development model is the same in either case, in particular for cross-cutting concerns such as packaging and deployment, security, integration with the companion application, and end-user skill discovery. And to an end user, a skill is a skill regardless of how it was built. So based on those two concepts, the Alexa runtime is broken down into these following three broad categories. There is the spoken language understanding layer that combines all the components that turn spoken utterances into intents, the application layer that turns intents into directives, and an orchestrator that manages the life cycle between those layers and determines the best course of action based on factors such as context, state, interaction history. So let me talk a little bit about the spoken language understanding layer of Alexa. So all the components of the spoken language understanding layer rely on statistical models. We do not hardcode the interpretation of spoken utterances, but we learn and adapt based on usage. Alexa will continuously learn what users sound like in various acoustic conditions, far field, close talk, and we capture that in what we call acoustic models. What users say, which we capture in what we call language models, and what users mean, which we capture in what we call intent classification models. Those models are global across all users and are further refined by incorporating personalized data such as your music library or your geolocation, for instance. We leverage AWS, as you see here, extensively, both for global and personalized models, so S3 for global models that are large, and DynamoDB for smaller models that we can update on the fly as users interact with an Alexa-enabled device. When you use the Alexa SDK, you also play a role in teaching Alexa from these artifacts, the intent schema and the sample utterances. You build and deploy models that look exactly the same as ours and then run alongside ours in the same services. Also, if you develop a custom skill, an important thing, given the statistical nature of the system, is that you do not need to provide an exhaustive list of samples, just representative samples. Alexa will learn and infer and generalize from those samples and is robust to variations in speech input. So for instance, if you have two samples here, one which is give me the horoscope for Virgo and one which is what is the horoscope for Leo, the system will generalize to phrases such as get me the horoscope for Pisces, where both the phrase and the slot have not been seen in the sample utterance set. All right, so that was the spoken language understanding part of the system. Now let me talk about the application skill orchestration layer. And I'm going to take you through a few scenarios here. This is a simple case of where we have a built-in skill. Let's say that the user says, play me some Van Morrison. The spoken language understanding system here decides that it's most likely a music intent. The orchestrator routes it accordingly to the music skill, built-in music skill that we've developed. And then the music skill implementation decides that for this particular request, playing Gloria is a good course of action, based, for instance, on the user's music library, on the music providers that the user has configured. And the music skill then uses the core AVS interfaces that we've seen to send back a collection of directives to the Alexa-enabled device. In this case, a text-to-speech directive with a preamble announcing the song, playing Gloria, and a playback directive with a URL to the actual song. Okay, so this is another example of skill orchestration. Here, now let's imagine that the user says next while listening to a playlist. That utterance is ambiguous. What does next mean? Who is it destined for? It could be music, it could be flash briefing, it could be while you're listening to a book because you want to progress to the next chapter. So in these cases, the platform will arbitrate when there is this type of ambiguity. Similarly, let's say the user says play. What does that mean? Does it mean play a song, play a movie, play a game? That also depends on things such as context, real-world catalog data, relevancy, interaction history, and on the output device. For instance, does it have a display or not? All factors that Alexa takes into account when routing an intent to a skill. So for this particular case, where we have an ambiguous next intent, the platform orchestrator manages something we call a content focus. So at any given time, we keep track of which skill issued commands to the audio player, and when this intent comes in, we give that skill first dibs at handling it. So that's how we handle context. And again, this applies equally to our core built-in skills and skills that you build with our SDK. All right, so this is an example of a custom skill, just to show you that it's exactly the same as a built-in skill. This is the get horoscope example that I think you saw before. So in this case, Alexa classifies the intent as being get horoscope. We route it accordingly to a custom skill. That custom skill runs business logic. They are typically deployed in Lambda functions, but they can also run behind a HTTP server. And that skill then will use the AVS capability interfaces to produce a response back to the device. Now I'm going to give you yet another example. So so far we've seen examples of handling intents. The connected home skill, which again, if you haven't seen it yet, you can go to on the floor that we have a greenhouse that's been set up, and you can issue commands such as turn on the fan, turn off the fan, turn on the light, and that uses our connected home skill. It supports an extension API. If you want to plug in your appliances that conform to the type of commands that we support today. And the API we have today is called the lighting API. So it is very similar to developing skills, but the development artifacts you produce are slightly different. In this case, you do not operate against intents. The connected home skill allows you to tap into an existing home automation voice experience. Here, the intents are defined and handled by us. We interpret the intent. We identify the targeted appliance type. We produce a directive that we then delegate to an extension you can write as a Lambda function. For instance, here, an utterance of the form turn on my kitchen light is turned into a switch on intent with kitchen light as the appliance value, and the connected home skill maps that appliance name to a given appliance ID and appliance type, and then forwards the directive to the lighting skill extension for that specific device type. And we'll see a little bit later how that map of device types and device IDs to devices or appliances is initially populated. So now I will talk a little bit about the machine learning aspects of our platform and how it continuously learns and how Alexa continuously improves. We do both offline training against large data sets that we collect and online training in real time as users interact with our system. And I'll show you examples of both. So this is the offline process flow, if you wish. It leverages pretty much every AWS service you can imagine. Data is collected first at scale from various sources, in particular users' interaction with devices such as Echo. The data is then transcribed and annotated through what we call, or what one's called a crowdsourcing process. This is the basis for what is referred to as supervised machine learning, where observations, in this case what users say, or the audio of the spoken utterances, is associated with the corresponding ground truth, meaning what they said and what they meant. That data, once annotated, once transcribed, is used to train various predictive models, which we do with a combination of services such as Amazon Simple Workflow, Elastic MapReduce style services, and against various EC2 clusters, including GPU clusters. Those models are then evaluated to ensure that there are no regressions, and then finally deployed when they are satisfactory. So this process is continuous and ensures that Alexa is always learning. Okay, and now let me show you another machine learning scenario, an online scenario. So I'm going back to the connected home example we saw earlier. And this illustrates how you don't, by using the SDK, you do not just plug into the Alexa ecosystem, you also get personalization and on-the-fly model training and model updates behind the scenes for free. So one of the features of the connected home skill is discovery. So if a user says, discover my appliances, the home automation, or the connected home skill, will query all the known registered providers to ask them to return back the appliances that they control. So here, okay. So here the intent coming in when I say discover my appliances is a discover appliances intent. That is turned into a directive that looks just like the directives you have to handle when you integrate with the AVS API. In this case, it's a control directive for discovery that goes to all the extensions for the connected home skill. They will then each return the appliances that they control, their names and identifiers. And the connected home skill will now keep a map of that so that when you later issue commands such as turn on my kitchen light, it will know how to route that to the appropriate Lambda extension. But one thing that's interesting here also is that in addition to populating this map, The connected home skill will now also use that as a catalog. Now it knows what are all the names that a user may use in a sentence when they refer to their appliances, and that catalog can now be fed to the spoken language understanding system so that it can also provide better results and know what the user is the most likely to say for that particular skill. All right, so that was a very quick peek into how Alexa works under the hood. If you have any questions, please come up and talk to me after this presentation. And I'd now like to welcome Stephen to talk about what BMW is doing with Alexa. Thank you.
Okay. Thank you for inviting me here today. I want to talk about smart agents and why they are very interesting to BMW. So we know that the automotive industry is going to go through some massive changes. So for example, we're living in a more sustainably conscious world. That means more and more cars are becoming electrified. So BMW has built the all-electric i3 and plug-in hybrid i8 to lead innovations in sustainable mobility. There will also be many changes inside the vehicle. The human-machine interfaces, like touch controls and gesture controls, we're going to be seeing more and more interaction modalities coming into the vehicle as well. And so in our latest iDrive system in the 7 Series, we have the first production gesture control system, where you can reject a phone call with a simple swipe of your hand. We're also seeing more and more vehicles connected to the driver. And BMW has always been at the forefront of this, and has always been a leader in providing vehicle data to its drivers. However, with the BMW i, we had to take this connectivity even further to satisfy the needs of an i3 driver. We discovered that information like state of charge and range were very important to an i3 driver. And they needed to know this information everywhere they go. So we developed smartwatch integration that gave drivers a quick glance at their vehicle information. Now, drivers can quickly see their state of charge and range, as well as where their vehicle is, if it's plugged in, and how to get back to their vehicle, all with a quick glance on their smartwatch. We also deliver vehicle information and range maps to your smart TVs. And of course, we have smartphone applications that give an even more comprehensive overview of your vehicle. Not only do you get vehicle information, you can also command the vehicle to lock your doors or even precondition your car. So at BMW, we're always innovating and looking towards new interaction models and new ways for consumers to consume our data. So what's next? Personal smart agents. We see a large trend in personal smart agents. They are currently everywhere in our lives. We're talking to our smartphones, we're talking to our smartwatches, and we're talking to our Echo devices inside the home. We're getting information and we're commanding actions just by asking for it. And because you're using your natural language, they are very easy to use and understand. We think smart agents are a very natural way to interact with your vehicle. And we want them to know about you as well as your vehicle. So when the Alexa team at Amazon came to us and demoed us the Echo device, we were pretty excited. I think several of us from the office immediately ordered one right after our initial meeting. So we were really excited about the possibilities of what the Alexa platform can bring to the vehicle. With the Alexa Skill Kit and Alexa Voice Service, there can possibly be a very seamless experience from from inside your home and then bringing Alexa into the car. We also like how open the Alexa platforms are. And this really allows us to prototype and really experience how it would be like to integrate a personal smart agent into the vehicle. So with our excitement, we built a prototype BMW skill for Echo that would add the vehicle context to Alexa. We built this on top of AWS, and it was really easy to build. With the BMW skill now, or with the prototype BMW skill, users can now request for vehicle information through Alexa, as well as execute vehicle commands through Alexa as well. And so now, I would like to show you guys a quick demo of our prototype BMW skill with Alexa. Alexa, open BMW.
Welcome to the BMW Alexa experience. You can say things like, "What is the status of my car?"
What is the status of my car?
Your car's charging level is 70% and you have 43 miles of range.
So this is actually using real live data from a real car that we have back at our office. Unfortunately, that's in California. We tried to get the car here, but... And if you're like me, I'm the type of guy who always forgets to lock his doors when I go home. So now, with Alexa, Alexa, ask BMW to give me the door status.
Your doors are unlocked. Would you like me to lock your car?
Yes, please.
Okay, I will lock your car.
Oh. So I make sure my car's unlocked, because I'm pretty far away. So I think this is just scratching the surface of what we believe is possible with the Alexa platform. Thank you. And back to you, Don.
Thanks, Stephen. Really, really fascinating stuff. You know, when we first developed the ABS tools that we had, we threw them out there. We had some idea of what people would be doing with it, but we really didn't know. And so we were super excited to begin working with BMW and explore the possibilities in the automotive space. So thanks again to them. So thank you, everybody, for coming tonight. That concludes the presentation. So before you guys walk out the door, for those of you were lucky enough to stay here, we're actually doing a random drawing to give away a few Echoes to everybody that had badged in to this presentation tonight. So the names should already be up on the website. So if everybody visits bit.ly/app store giveaway, and your name appears related to the session that we've had here today, you have won a free Echo device. The catch is that you only have 30 minutes to collect it, so you have to go to the gaming alcove here on the 4th floor to collect your free Echo device. And again, that's bit.ly/app store giveaway, so don't forget to take a look at that. And finally, you know, if you've attended more sessions, you know that we really like to get feedback from you on how we did here today. That's how we improve our talks. It's how we improve reInvent and make it better every year. So in your reInvent application that you have on your phone, you should have been invited to fill out a survey on this talk. I would encourage you to do so. We'd love to hear from you, hear how we can make the show even better next time. So thanks, everybody. Enjoy the replay party tonight and enjoy the rest of the show.